Hey guys, Grudy is here, and this is the video for converting to slope intercept form. So you guys, if you haven't watched the videos on slope and on slope intercept form, go back and watch those first, please. So when we're graphing linear equations, when we're asked to graph an equation or we're asked to graph a line, it's really nice to have that equation in slope intercept form because it makes graphing a line really easy. I mean, of course, there's other ways to graph, but life's a little bit easier when we're able to graph when our line is in when our equation is in slope intercept form. The reason why is because we automatically know two really important pieces of information that make it really easy to graph. We know what the y-intercept is, and we know what our slope is. So with those two pieces of information, it's not hard to graph a line. Okay, so if the equation's not in slope-intercept form, but we can recognize that it's a linear equation, then what we want to do is we want to convert it to slope-intercept form. Here's what I mean by that. Whoops. So here I have a linear function right here. One reason why I know it's a linear function, I have an x variable, I have a y variable, and there's no exponents of any kind. Okay, so I have an x, I have a y, there are no exponents. This is a linear function. Now, does it look like it's in slope-intercept form? No. Whoop, my pen's going crazy right now. I don't know why. It does not look like it's in slope-intercept form. It's just in y equals mx plus b. Sorry, guys. Because it's not in y equals mx plus b. Okay, and so therefore it does not look like this. But what we could do is we could solve for y in our equation and change it, put it into y equals mx plus b. Okay, so here's how we would do that. All I would want to do is get y by itself. Okay, so I would just start solving this equation for y, and it might look like it's in slope-intercept form. So to get y by itself, I've got to move over this minus 18, and I've got to move over this 6. So I would just do the opposite. So the opposite of minus 18 would be plus 18. That cancels. I've got 6y. And I got to, whatever I do to one side, I have to do the other. That equals 3x plus 18. Some of you might be able to see, okay, it's already starting to look a little bit more like slope-intercept form. And then to get the y by itself, I just divide both sides by 6. But when I divide by 6, I have to divide everything by 6. Not just the 3x. I also have to divide the y-intercept by 6. And I'm left with y equals 3 divided by 6 is 1/2. Sorry, I don't know why my pen's going crazy. So I got 1/2 x. And that would be plus 3. Okay, so now I've got an equation that is in slope-intercept form. Okay, and so I can just graph this as I would normally graph any other line. So this is the exact same thing as this. Okay, so don't be fooled. They are the same thing. It just is written in a different way. Okay, and so now I can graph it by starting from my y-intercept at positive 3. So here's my y-intercept. And then I can use my slope as rise over run of 1/2. So that's up 1 over 2. Up 1 over 2, or I could go down 1 over 2. And then there is my line for this linear function. Okay? Let's look at another one. So we've got 8x minus 4y equals 16. Again, nothing even close to slope-intercept form, but we want to put it in slope-intercept form so it makes it really easy to graph. Okay, so I need to get y by itself. So the whole goal of slope-intercept form is once you solve for y, it should be in slope-intercept form for the most part. So to get y by itself, I've got to get rid of this 8x, and I've got to get rid of this negative 4. Okay, so what I want to do is I want to move over the 8x first. Always move over, if the x is on that side, always move that over first. So I can subtract 8x from both sides. These cancel. I'm left with negative 4y equals negative 8x plus 16. Now notice how I wrote my minus 8x before the 16. I could have done 16. I could have written it as 16 minus 8x. I could have done that, but this isn't slope-intercept form. Okay, slope-intercept form is y equals mx plus b, so my x is normally in front of my y-intercept. This, I could leave it like this, it doesn't matter, but it just doesn't look as familiar, and so I don't like doing that. Okay. And so now I got to figure out, okay, well, what's the last thing I need to do? Well, it looks like I need to get my y by itself. In order to do that, I need to divide by -4. Okay, that gives me my y by itself. But whatever I do to one side, I have to do to the other. And I have to divide both pieces by -4. -8 divided by -4 is positive 2x. And then 16 divided by -4 is -4. So this, again, is the same exact equation as this. I mean, these are the exact same thing. They represent the same linear function. If I were to graph this from here with a input-output table with an xy table, I would get the exact same line that I'm going to get from graphing this equation right here. They just look different. Okay. And so now I can graph starting from my y-intercept -4. 1, 2, 3, 4. And up to over 1. And again, it's up to over 1 because there's no denominator, but it's rise over run. I can put 1 down there. And there's my line. Okay, let's just look at one more just to make sure we've got this. Okay, so now it looks like I've got my x on the left side and my y on the right side. That does not change anything. I still need to get y by itself. This equation looks like to get x by itself might not be very difficult. Okay, like, oh, I can easily get x by itself. All I do is divide it by 3 and I'm done. But I don't want x by itself because slope-intercept form, it's the y equals, not x equals. So I still need to work on getting y by itself by moving over this 10 first. Okay, move over the 10. So I've got 3x plus 10 equals -2y. Okay, and now I want to get y by itself by dividing by -2, but I have to divide everything in the equation by -2. Those go away, and I get y equals -5. And this is -3/2x minus 5 equals y. Now this is backwards. Okay, so I've got the y on the right side and the rest of my equation on the left side, but it doesn't change what my slope is and what my y-intercept is. My slope is -3/2. It's the number that it's attached to the x, and my y-intercept is the constant. Okay, so is -5. So I'm still going to start from -5. All right, and then I'm going to go, let's see, normally I would tell you guys to go down 3 and over 2. Okay, but because for the sake we don't have as much space on our graph that way, we're going to go up 3. So up 1, 2, 3 over 2. Up 3 over 2. Okay, and there's my graph with a negative slope. So it looks good to me. Okay, so guys, the biggest thing is whenever you have equations that are not in slope-intercept form and it asks you, well, what's the slope of this line? What's the y-intercept of this line? Or graph this line? Anything along those lines, you can always just put it in a y-intercept and you can put it in slope-intercept form and you can answer all of those questions. We know what our slope is, we know what our y-intercept is, and then now we can graph it. Okay, if you guys have any questions, let me know, and good luck.